All right, so for this question, the key part of this question is that we have to do all of this in place. So what that means is we're not going to return anything new. We're going to modify the link that was passed, the linked list that was passed into us. So I'm going to write up kind of almost like a pseudo environment diagram to illustrate this purpose. So I'm going to create a different link because I don't want to write as big of one as all right, so here we have this list example, which is going to be 1, 2, 4, 2. And then we're going to call removal of this list example of the 2. Okay, so now let's do like an environment diagram here. So in the global frame, we have this list X, and this looks like this. Cool. So this is what happens here. So if we think of our environment diagram, this list example, all it is a pointer to this first element in our list. Okay? This list example does not point to everything, right? This list example points to this first element. Okay, so you have to think of these lists as like, or these links as just like, they have one thing, they point to the next thing. That thing points to the next thing. Just like trees know nothing about their roots, this guy knows nothing about anything past here unless it like does dot rest, dot rest, dot rest. Okay, and obviously like remove all is gonna point to a function. This is not like a perfect environment diagram, but it's just to illustrate the purposes of this question. Okay, what we want to happen, what do we want this to look like at the end just logically? We want to remove this 2, this 2. We want the answer to look something like right? This is what we want it to look like in the end. And that's what we want list example to point to at the end, is this guy who all he has left in his list now is a 4. We're not going to return anything, we're not going to print anything, we're not going to do any of that. Cool? Alright, so let's think about how this is going to work. So we have the first time we call it, it's going to have a link and a value. Okay, the first time we call it, what does this link point to? Anybody? This link is just going to point to this first element, because we pass in list example, which points to the first element. Cool? And value equals 2. This is the thing we're looking for. Okay, now if you read the directions closely, it says you're never going to remove the first element of the list. Right? So the reason why that's important is now, well, if we can ignore this one, let's just say we know this one is not going to be removed. The first thing we want to check is, okay, is this one going to be removed? So it's tempting to just say, okay, we're done with this one, let's check this one. But really, if you think about what we want to happen, we want this now to point directly over there, right? So really we need to do the work of removing the 2 when you're right here. Okay? You can't, once you get to the 2, you can't get rid of it once you're there. You can only like skip past it. Okay? So So we have our function. What is it? Is it called value? Yeah. Okay, cool. Okay, so this is definitely going to be recursive. It's a recursive object. We're definitely going to use recursion. Let's think about our base case. Right? Well, our base case, what if we pass in an empty list? What if we tried to say, okay, this L1 equals link.empty, and we try to remove all 4s from it? Nothing's going to happen, right? All right. So we can just return. We can literally just leave the function. Okay? What's our other base case? What if we're passing just a list with one element in it? Then we know we're never going to modify the first element, right? So we don't do anything, right? How can we check if it's like just the last object of the list, or it's a list of only one? Link.rest is link empty. Cool. So that's our base case. Now we know that there is something next in our list. So we have our two cases. We either want to get rid of it or we don't want to get rid of it, right? Okay, let's say we do want to get rid of it. And okay, so we're right here. We want to see if we're getting rid of this element. How do we get this element's value? Link.rest.first, right? And more importantly, we're guaranteed link.rest is a link based on this, right? It got through here, so we know we can do this. You have to be careful with these lists of trying to do like link.rest.first if link.rest is empty. Okay, so if link.rest.first is equal to value. Okay, so now we're in the case right here. This is link. Value is 2. Link.rest.first is 2. Okay. How can we get rid of 2? Well, we can say instead of pointing rest to 2, let's just skip over it. Right? And then that 2 is essentially gone. There's no way to get to it anymore. Because if I say this now points to the 4, then now this link.rest equals 4, there's no way to get to 2. It's essentially deleted. It's out of our list now. You don't have to worry about like this pointing to this. It's fine. It's gone from our list. Okay, so how do we do that? Well, we can say we want to change this link.rest pointer. What do we want it to point to? How would we get to 4 normally? We would say link.rest.rest. Right? So now link.rest equals link.rest.rest. So now, what's important here, this link element points to this, right? I have literally gone and changed this object, and for all intents and purposes, 2 is now gone. But what's important now to realize is list example has now changed. If I try to do list example.rest, it now points to 4. So without returning anything, I've changed list example because they're all pointers. Okay? So now I've done this. Now essentially what I want to do is the same exact thing, but see if 4 is our value, right? So link, I'm still trying to check like link.rest, so I can just recursive call it. Cool. So now if we go into here, and let's say we're here, now we're going to call it again. Now, link is going to point still to this first element, and value is still going to be 2. Cool? But now we get to the case of the else. This link.rest.first equals 4. So that's not equal to our value. We have our else statement here. Now what do we want to do? We essentially want to say, hey, I've checked like first, like this one's next and it's good, or rest and it's good. Now essentially what I want to do is check this one's rest to see if it's good. So now I'm going to change my pointer and say, well, now link is equal to link.rest. And now I'm going to check it. Okay, so now I've created a new one. Now link though in this frame points to that. List example, our original list example still points to the first object, but in this call, link is going to point to here. Now, we check, is link list.empty or is link.rest list.empty? No. Is link.rest, here's link.rest.first is 2. Is that equal to value? Yes. Now I'm going to say link.rest equals link.rest.rest. So I'm going to go in, actually modify the list, and say, now 4 points to the empty list. Now, according to our logic here, we've done that. Now we remove all of link value. So now we call it one more time. Value is 2. Link still points to this one. But now we go here. Is link list.empty? No. Is link.rest list.empty? Yes. Okay, return. Now we're done. And now, if we say, okay, like after this, if we say, you know, list x.first, 1. If we say list x.rest.first, list x.rest.first is now 4. We've gotten rid of the 2 from list x without returning anything, without printing anything, we just modified the actual objects. Does that answer your question? Cool. Everyone good with that? Everyone have any questions or anything they didn't finish in the lab they want me to go over? Cool. All right. Get started on ants if you guys haven't yet. It is time consuming. There are weird little bugs that you will find.
Is that a pun?
Huh?
Is that a pun?
Oh, that was a good pun. Yeah, that was on purpose. Cool. All right. Yeah, feel free to come up and ask me questions. Otherwise, I'll see you Thursday morning for discussion.
Can you take this real quick before you go?
So
Yeah.
this link, so these modify the original link, and then this one's only like its own link. Because like when you ran it again, it modified like the original link.
Well, each of these objects just exist instance, right? And this example, all it is a pointer to this, right? This one happens to have a pointer to another object and another, right? So here, when we say link.rest equals link.rest.rest, we are changing the pointer of this object to point to something new. But this still points to the object. So it essentially modified what it's pointing to without actually like changing it. Okay. Does that make sense? So list example the entire time still points to this first object. We just changed what happens at the end of this. Okay. Does that make sense? Yeah.